Hi, welcome to Simulations. So in this video, we're going to go over how to track the defects in rework of any operations. In this case, we're going to mimic a manufacturing company going to a milling process and a grinding process. We're also going to learn how to use the uncertain routings to be able to track these inspection defects and rework. And at the same time, we're going to learn a new command for increment and decrement to track the inventory of these defects and rework. Anyway, this is from our previous video on that we discussed in the past on company Southern California Forgings. In this case, the situation with this is we need to add a inspection process. So below we have the milling and grinder process, but now we need to add an inspection process. Based on these inspections, we add this location, and this inspection will take care of the conditions of the parts after the grinding process. But guess what? The conditions are as follow after our inspection process. So we had a 5% scrap. We also have a 12% of all the spar that goes through the process after the grinding. 12% will have to go back to the milling process. So this the first step, and then 10% will have to go back to the grinding process. And in this case, in this model, we're going to assume the same processing time. Okay, that means that the balance of all of this will continue to the finished parts, and then it will count the total good production. All right, so let's see how we can get to this into Promodel. Okay, so now we're going to have to add a few locations in this model. Remember the previous model, we already built it. So they say that we need to add an inspection process. So this is where we create the inspection location with a capacity of 1. And then from here, it says that there's some sort of scrap and rework. So let's go to the grinder rework. So we need to create staging areas where we can put away all these parts, and we're going to create one for the grinder with the infinite location, and also the scrap. This is also another area where we need to create a staging area to put away all the bad defects, and another one, we already have the finished parts and the milling rework. Okay, so the milling rework is the one that also is a staging area. I can actually move this if you want to move this just above the finished part, so that we already know that this is the sequence. So at least you know that the last location is the finished part. Okay, so now I'll go to my processing. The arrivals is the same. Now a new location for inspection. We can go ahead and insert a new record. Wait a minute, this is not the one that I needed to do. So it has to be in between finished parts. Let me see, insert the record. There you go. So after the grinder process, they said that there's a new inspection process. So the location will be inspection. Right. And from here, according to the inspection time, it was a triangular distribution. So between 6, 8, and 12 as max. All right, so the output that we're going to have, remember in the grinder, the output was to the finished part. So now we need to fix this to the inspection area to make sure that we're okay. And then from the inspection area, and this is where it's going to get the uncertainty on this model. Now we have multiple destinations, right? This is where After inspection, we make a decision where there's a defect or not. And we're going to see if, let's see, the destination might have different options. So the different options may be, okay, I have a optional to go to the milling rework, right? So, and this is where we need to make the changes. If I leave it as this, that means that everything is going to go to the rework. So that means that I need to create a new routing rule that says I don't want everything to go to the milling rework. What I want to do is just a portion. So the probability is that the milling rework in this case is 12%. So now I select probability and then put here 0.12. Right. Now, there's also another destination. After I do my inspection, this is also going to another rework probability. So I need to create now another line. Just make sure that you don't create another block. It's another line that says there's also forgings that may have a destination for grinding rework, right? So in this case, the rule for the grinding rework is not everything, just a portion or a probability that it's only, in this case, was 10%, according to our problem statement, all right? And also we know, just make sure that you don't create blocks, new entity blocks, it's just in the same one. The output, I'm going to have also another option. So these are options or uncertainty routes that says I'm going to also have some sort of a scrap, right? And the scrap, I think the problem statement says 5%. So now I put my probability of 5% here. Okay, so now I have rework for milling, rework for grinding, and scrap 5%. But guess what? There's another destination. What about the balance? The good parts. So these are, everything above is bad parts. So let's put a forging for the good parts, the one that passed the test, to the finished parts destination. And obviously the balance, remember all these with percentages, the balance is 0.73 are the items that pass the inspection. So all of these 12, 10, 5, and 73 needs to be equal to 1. Alright, so now based on this, I create my destinations. So now I can create my new records of areas. Remember, all those three are created here now. And I can say the inspection goes to my milling rework, okay, location. And then the output is a forging that goes to the mill machine. Okay, so I need to insert another one for the same thing, forgings that came from inspection. So from my area of allocation, and then the destination is going to be the grinder. Okay. So remember, these are staging areas for rework. And also I'm going to have another one related to my scrap. Okay, this is where I'm going to send. This comes from the scrap area. So my holding area for scrap. But guess what? Where does the scrap goes? Well, these are bad parts, so I don't have anywhere but just send them to be out of the plant. So this is where I create another exit. So this is the first model that you learn where we have two exits. One is for the scrap because it doesn't have any more work to do. and the other one is the finished parts. Okay, so I'm done with my processing, right? And one of the problems is they want me to track the work in progress. So as you can remember in the previous model, we use the WIP, right? Equals WIP plus 1. And at the end, this is just to increment the variable. Then we have the WIP plus WIP minus 1, right? So this is what we learned in the previous model, how to create those variables. But in this case, the other objective of this class is to learn how to use the increment. So in this case, I'm going to highlight this and put his increment. So this is the new command that you're going to learn. It is going to have the same function of increment. The WIP is the same thing as WIP plus 1. And in the case of minus 1, I'm just going to make a comment here. Remember, the forward slash is the double forward slash is to make comments. So in this case, I want to put decrement. One was the increment, and the other one is the decrement, the WIP. So those are the two things that you learn now. Instead of writing the formula, I just put decrement, which means WIP minus 1. Okay. Oh, another thing that I have that we have to do an update is in the moves. So remember, they say that the move time between machines, it was 1 minute. So we don't have any resource allocated, but all we need to do is to add the move time, move for 1 minute, and make sure that move for 1 minute. So there's going to be somebody doing this work. So you just add more lead time, move for 1 minute. Right. And this don't go into a machine, so that means this is assumed to be the same. So, okay, so I'm done with my moves, and my wait times are the same. I'm supposed to be the same. And what else I'm going to do? Okay, they asked me to track also the work, the amount of scrap and rework. So that means that I need to create new variables. Okay, so I'll go to my variables area where I can do the total scrap, right? And as you can see, I have already allocation for a scrap where I put my accumulation. So I'm gonna put it here. Okay, and I have my total grind rework. Oh yes, I'm just gonna put here grind rework. I'm gonna put also my milling rework, total milling rework. Since this is a scrap, right, I'm going just to try to put a fill with red. You don't have to do it, but just for aesthetics. Okay, so I'm pretty much trying to answer those questions to track the WIP here, total production, and since there's a lot going on of rework, I expect that my WIP is going to go up. As before the model, we didn't have any inspection, so there was more production, but in this case I'm expecting to have less production because of this process of rework and more scraps. So that means that the output is going to be less total production, but guess what, the WIP is going to go up. So that's my expectation. So WIP, I'm also going to add the increment total production, right? Now, if you, for any reason, don't know the name, you can use the builder, logic builder here, and in this case, just use the command of increment, and it comes here, production. Right. So now also, I want to know, see if I have my scrap. In my scrap, I also need to, I forgot to put the tracker for how much it goes out, because if I just put the decrement on the WIP, I don't know, I'm not taking into account what goes out in a scrap. So that means I also need to put here a decrement, the WIP, so that things that comes out, it takes it into consideration for the things that are in between the processes. So I also need to decrement the total scrap here, decrement the WIP, sorry. Okay, so now I have my total things that come in as increment the WIP, and then decrement at the finished parts, and also decrement at the scrap area. Another question that they ask is to track the amount of rework for milling, grinding, and scrap. So I need to build a tracker for rework for the milling process. So that I'm going to use the INC, increment the total amount of milling rework. Okay, and again, you don't have to type, you just have to just select the area, use the builder, it's less typing, or you can also type directly. And this is total grinder, paste, there you go. But guess what, I also want to know what is my total scrap. So now I'm going to have to do an increment the variable called total scrap. All right, so with this, I think I'm able to track everything that they asked me in the problem in tracker, and also the increment of grinding rework. So okay, so I have now pretty much everything done. Let me just do a double check, increment the WIP, there you go, and the weight statements. So my scrap and everything comes out my total production. Okay guys, so now let's fire the model. Okay, I'm starting to see production going out, scrap going out, milling rework staging, my grind rework, my WIP also as well, and total production. So that means that everything is working as I expected. WIP start to go up because all of this area, this machine probably won't be able to handle the load of, and this is what I have seen in companies when there's problems in a scrap, there's problems with quality. So you'll be able to highlight the issues and estimate what is the financial impact of these issues of bad quality to the products using this modeling. And that's precisely one of the things that, look at this, this whip is going up. So let's turn off the animation and wait and see. All right, as you can see, there's a lot of blocking. Looks like they would not be able to handle the load. And like again, this is very common in companies that have issues with quality. All of a sudden, there's a bottleneck going on, and a lot of inventory start to go up, a lot of WIP. So these are the results of the analysis. So looks like the total production was 41. The maximum value of the inventory is 580, and this is the average. So total scrap maximum 312 and rework 571. And so if you add all of this plus the production, 312 is about near to the 5%. Right now, let's take a look at our time plot to see when things you can actually provide this information to the company and predict when there's going to be a problem. Okay, look at this. So the amount of inventory, let me just uncheck these location areas and select the WIP. So you can see, you can predict the issues that of inventory accumulation, what's going to happen if there's problems in quality, the detection of defects and rework. So in this case, you need to let them know that the capacity to handle this situation is going to affect the working process. Therefore, you need to make changes, adding additional rework stations or incrementing the capacity of the machine, or just attacking the problem right away, because this is not going to look good. All right, guys, so I hope that with this information you have now a way to predict the issues, the effects of quality inspections, defects in a scrap, and rework as well.